All right. Hey, everybody. Can you hear me? Is this on? All right, excellent. Okay, well, it's kind of loud in here, so I'm going to have to project. If it sounds like I'm screaming, it's because I am. That's what's happening. So we have some slides. Where are they? Slides? Where are the slides? That's a question. Well, while they're getting oh, here we go. Great. Awesome. Well, I hope everybody is having a excellent time here at Big Data London so far. A little bit about me, just to start off. My name is Chad Sanderson. I'm the CEO of a company called Gable.ai. We're a data management and data infrastructure company focused on shifting data quality and data governance to the left. But before I was a founder, I've run data platform teams at a few different companies. I ran the data platform team at a late-stage freight technology startup called Convoy. I was also a tech lead on the AI platform team at Microsoft, which nobody used to really know, but has become a lot more famous over the last year and a half or so. And today, we're going to be talking about something that's very near and dear to my heart, which is data contracts. But before we get into the what of data contracts, I want to talk a little about the why. Okay, so there's some numbers on the screen that you're seeing here. First one on the left is basically the ratio of data producers and software engineers to data engineers at most companies today, which is 50-1. And that's usually on the conservative side. In most cases, especially at really big businesses, at tech-oriented companies, this ratio skews closer to 100-1 or sometimes even 200-1. And when we're talking about incidents with data quality or data governance or PII mismanagement, the vast majority of the root cause of these issues is coming from these source systems. So the data producers that are making changes to their data over time. And what this causes is your downstream data engineers to spend the majority of their time working on more ad hoc, one-off data quality tasks, fixing bugs, solving a problem that someone sees with their dashboard, and so on and so forth. So I call this group of people data developers. So these are engineers. It could be a data engineer, it could be a data scientist, it could be an analytics engineer. The majority of their time, in most cases, is being spent on non-scalable work. So these are one-off ad hoc solutions or requests that are oftentimes coming from the business or other data teams. Whereas where these people really want to be spending their time is on the scalable work. Right? It's talking about infrastructure, what is our AI strategy, what's our data security posture, and they just don't have time to do that. So when businesses begin investing in artificial intelligence, Gen AI is obviously a very current example of this. I'm sure most people in this room have had an executive say, what are we doing for Gen AI? These types of products that leverage AI or machine learning or data in some way, require these data developers to spend their time answering some critical questions. Here's a few of those questions right here. Number one, what is the source of truth of this data? Nobody wants to build a model on data that is fundamentally untrustworthy, right? Number two, can I trust it moving forward? Is it going to change out from underneath me from day to day? Number three, what does this data actually represent in the real world? Semantically, what it means. Maybe what a table looks like, sort of when I'm just checking it out and looking at the fields and the values, it's different from what the producer actually intended the data to mean when they created it. Is it stable, and can problems be very quickly remediated if there is an issue? And what all this really boils down to is that is there someone who is accountable for this data and treats it like a product? Now, I think as data professionals, we are very focused on that set of problems, right? Because the data developers are usually our customers. These are the data scientists, the data engineers, the analysts, the product managers, the other business users that need data. But there's another very important persona or stakeholder in this workflow, which is the producers. It's the people who are creating all the data in the first place. And oftentimes, they have questions too. So something I noticed when I was at Convoy and I was trying to figure out why we were experiencing constant data quality and governance issues is I went to these producers and I said, hey, do you guys even know who is using your data or what they're using it for? And they said, yeah, we have no idea. We created this data to serve our needs, which is oftentimes operational, some sort of transactional database, and we're not thinking about what happens to the data after it gets handed off to the analytics platform or the data platform team. And they have a lot of questions as well. Number one, who is actually using my data in the first place? Do they know that? Number two, what are they using it for? Right? If someone is using data to create a dashboard that one person in the company looks at, that's very different from if someone's using it for a machine learning model that makes 100 million USD, or if they're using it for the financial accounting. These are all very different things. Thirdly, is it actually being used in the correct way? Is the intent that the data producer had when they created that data asset the same as the way the data is actually being used? When do new data dependencies exist? And then finally, is this data something that I need to be accountable for, right? There's a lot of data in a company. I'm sure you guys have attended some talks today. I mean, it's called Big Data London. There's a massive amount of data in most organizations. If a producer was accountable for every byte of data that was generated, that would be their only job, right? So their goal is to focus down and say, what are the important bits that I should actually care about? So data producers and data consumers both have really critical questions, and these questions are required to be answered before the business as a whole can invest in data products like AI. And unfortunately, these two sides both have the answers to each other's questions, right? The producer has the answer to the questions of the consumer around, is this data trustworthy? Where does it come from? The consumer has the answer to the producer's questions around, what is this data being used for? But these two sides do not actually communicate with each other very frequently, and that's a problem. So why is that communication very difficult today? Well, if you think about the flow of data within an organization, right, just to lay out a simple example, oftentimes you have maybe events that are implemented by a software engineer in a code base. Those events are then pushed to a transactional database. Maybe you have some streaming system in the middle, like a Kafka or a Kinesis, and then the data lands in something like a Amazon S3 or GCS. And then from there, it's pushed into a Snowflake or a Databricks. And then from there, you've got dbt and a bunch of transformations. And then from there, at the other end, you've got Tableau. So the data that the data consumer is using looks almost nothing like the data that was initially created. These two sides are speaking quite literally different languages. The producer might be operating in JavaScript or .NET or Python, whereas the consumer is oftentimes operating in SQL or dashboards, right? So even if the producer wanted to communicate information about their data assets to all their consumers, it wouldn't be possible because there's so much technical complexity in the middle. And that results in a lot of things. It results in an enormous amount of duplication because the consumer doesn't really trust any particular data set created by anyone that's not them. So they'll just go and repeat the wheel and say, okay, well, you know, I've got a data asset that I trust, but I'm not going to take a dependency on someone else. And that problem is compounded by a lack of change management. So if the source systems are always changing, and I think at most companies these days, software engineers are encouraged to be as isolated as possible, to move as fast as possible, and you're seeing the decomposition of many monolithic systems into a bunch of microservices, and that means there's rapid change happening in a federated way, and nobody really understands how that change is going to affect anyone else in the organization. What does that result in? Number one, garbage in, garbage out. I'm sure I don't have to tell anybody about this. GIGO is extremely common. If you cannot fundamentally trust the data flowing into your analytical system, then you cannot trust any output that it produces. Secondly, your innovation velocity is slowed. You're not able to iterate as fast as you otherwise could have if everybody just trusts the data and you don't have to spend time validating and writing tests and doing all these things. Okay, so what is data management? Data management is the practice of organizing, maintaining, and securing data to ensure its quality and reliability across the data supply chain. So some people may have a different philosophical definition of me. Some people think that data management is a component of data governance. I happen to think that data governance is actually a component of data management, but whatever, ultimately the point still stands. But what may have stood out in that last definition is this use of the phrase data supply chain. What is that? Well, before we talk about the data supply chain, I want to talk about a normal supply chain. If any of you are in the logistics discipline or something that is tangential to logistics, you may have some familiarity with supply chains. But the manufacturing space, as an example, has been dealing with this problem of producer-consumer collaboration for over 100 years, right? You've got a farmer who's working on generating some raw material. That raw material is dropped off at some supplier. It's then pushed to a manufacturer. There's a lot of trucks that then distribute that to a retailer, turn it into a product, and then that product is ultimately sold to a consumer. Does that sound similar? Producer on one side, raw materials, consumer on the other side, data products, lots of transformation in the middle. Yeah, it's the same. It's the same. Data effectively suffers from the same problem as any industry that requires the handoff of raw materials between producers. And the supply chain industry, if you study them for a bit, has invested an enormous amount in things like supply chain visibility and central systems for operating not just the right-hand side of the supply chain, but everything from source all the way to destination. So a bit of a repeat of what I just said here. Okay, so what does the modern data supply chain look like in most companies? Well, on the right side of the supply chain, you've got a lot of investment into quality, into governance, into testing, in validation, in semantic understanding, and cataloging, and all of these really amazing, great things that start from the moment your data hits your analytical ecosystem. And this is great. Like, this is a big step up from where we used to be, which is there was nothing, right? And now all of this is happening in a much more federated way than it used to. But what we have today is sort of like the equivalent of if you have a real-world supply chain and the only visibility that you have on it is from the moment that the product actually arrives in the store, right? If there's any defect with the product, especially if it's a really important or critical defect, like let's say tainted meat, you would probably want to know about that before it gets made into a burger and sold to a customer. And so that's what you can see here. That's what you can see here on the screen, is all of that governance and visibility and change management and all the great stuff we're doing downstream doesn't actually exist in the upstream at all. So when you hear terminology like shift left data management or shift left data governance, this is what we're talking about. We're talking about taking all the data management and governance best practices and starting to expand it beyond the downstream for end-to-end coverage. So why is doing that so hard today? Why have most companies not shifted left yet? Well, the main answer is because data production is extraordinarily heterogeneous. You've got a large amount of different surfaces. So many surface areas and many different types of technologies and many different people who own those different technologies. So we're talking about software engineers who write code, and that code, like I mentioned before, is pushed to a database. We might be talking about salespeople putting records into a CRM. We could be talking about folks who are managing an ERP. We could be talking about third-party businesses that are handing us an API or an FTP. We do a big data dump and put all this data into our data lake. Or we could be talking about something else completely, but lots of different technologies, lots of different sources. On the data consumer side, however, we've started to do a good job centralizing, right? We usually, not in all cases, but in most cases, we have one data lake and we have one analytical database. And then all of our great data work is done on top of those systems. Okay? So Lots of data sources, very heterogeneous, a very small number of data destinations, relatively consistent. That's a bottleneck, right? That is definitionally a bottleneck. And so when we're talking about, okay, well, why do those big numbers that I showed in the beginning of this presentation, where data engineers and data developers are spending 70% of their time on validation, that's why. They are the bottleneck. And as the data bottleneck in the company, they are the ones ultimately responsible for quality issues, for governance issues, even if they were not responsible for them. Okay, so this is a pretty common workflow that I've seen occur at many different companies. I experienced this maybe 1,000 times in my career. And it sort of starts with a new feature. And this could be an engineering feature. It could be a new customer added to a CRM. It doesn't really matter, right? But you've got this new feature. It's developed. It's reviewed. There's a pull request that's opened. Other software engineers look at it. They approve it. It's good to go. Code looks fine. They deploy it into production, right? And then it turns out it breaks something on the data side. That could be a schema issue. It could cause events to stop firing. So the number of records that we expect from day to day, we're expecting 1,000 events and we only get 5. It could be a semantic issue. It could be some other business logic-based issue that the person didn't even think of. But one way or the other, the data is impacted. Well, now what happens? If we have a monitoring system, perhaps we can catch it reactively. And there's nothing wrong with reactivity. Software engineers use reactive systems as well. Datadog is an example of this. So it's good to have reactive systems. But if you catch something reactively, it means the problem has already happened, right? And who is that problem affecting? Well, it's usually affecting the end data product owner. So whoever's looking at your dashboard, whoever's maintaining your machine learning model, and they escalate that problem to the central data team, whether it's data platform or data engineering. And then whoever is now on the hook for that root cause analysis has to spend an enormous amount of time trying to figure out, well, what is the problem not? Was it just a random pipeline failure? Was it a change in the real world? Did the business change in some meaningful way? Did it come from the source? And once they identify, yes, indeed, it came from the source, they have to go figure out who that source owner was that caused the change, which is its own crazy, time-sucking endeavor. And then once they do that, then you got to say, hey, I need you to fix this. And of course, for a data producer, data issues are usually like a Sev 3 in terms of their priority, even though to all of us, they're a Sev 1. So it gets put on a backlog, and we have to wait and wait and wait. And then when they finally fix it, then we do a backfill. And then we go back to the data teams at the end of the day and say, hey, guys, your thing is fixed. But at this point, it's been weeks. Potentially, it's been months. And that loss of trust in the data and the platform team or the data engineering team has already happened, right? Pretty much worst case scenario. So as your business starts to scale data, what a lot of people think is, oh, well, we can just hire data engineers proportionally to keep up with the growing mess over time. No, wrong, incorrect. That's not what happens. The amount of people in a company that want to use data as it comes online grows exponentially. And the amount of data, so the volume of data that's actually needed, also grows exponentially. And so very, very quickly, what occurs is that all of these needs of data developers don't actually scale with incremental data engineering velocity. Okay, so this phenomenon that I'm describing right now actually has a precedent. It's not unique to data. It is true of every centralized team that is focused on quality and standards that has ever existed in the history of software and probably in the history of business. We used to have this thing called QA teams. Maybe some of you have been on a QA team. Maybe you worked at companies that still have QA teams. But at most modern tech companies, there is no QA team anymore. You know who's responsible for QA? The software engineers that are shipping the features. And why is that? Well, that's because businesses have realized that if you have a person whose only job is to think about qualities and standards, and you have another person whose only job is to ship products that make the business money, and you're trying to prioritize between which of those two gets the money and the resourcing, it's always going to go to the person who makes the money. This is the position that data quality and data governance teams are in now. We're fighting this impossible uphill battle because we're completely separate from the teams that make all the money in the company. And the way that these other various industries have solved this problem is to make that quality effort the responsibility of the software engineering team. They merge. It's not two distinct disciplines. So this is what I call federated data management. Federated data management is now taking all the principles of data management that we just talked about and applying them to both the source and the destination. It's a shared responsibility, not a centralized responsibility. So there are some components of federated data management that are really important to think about. First is data products and data contracts. My definition of a data product is any data artifact that requires a data contract. And we're going to talk about what data contracts are in just a second. You also need the ability to discover and trace where data is coming from. What are the data sources that you have, and how is data ultimately being used in your company? And then thirdly is governance as code. How do you programmatically enforce the standards that a central team has created all across the business without needing to do it manually? So data products, really exciting paradigm. There's probably a million bazillion talks on data products at Big Data London, so I'm not going to belabor the point that much. But it's this new paradigm that's effectively starting to think of data as a domain, as a microservice. And this is really meaningful in a few different ways. You've got your sort of architectural quantum in the center there, and you've got your operational system that produces that data owned by the same team, right? Oftentimes this was split down the middle where, product engineers owned your operational systems, data teams are owning the data products, quote unquote. And when you take this entire view sort of from a top-down perspective, you see that your company becomes very domain-oriented. Now, what I will say, this ultimately is the data mesh philosophy, right? I've worked with a lot of companies that have tried to implement data mesh. What I will say is that it's very hard, and it becomes a cultural initiative really, really quickly. If you want to know my personal opinions on data mesh, come and see me after this presentation. So we sort of get to the data contract, right? What is the function of a contract if doing all of this work culturally is very challenging? Well, people hear contract, and what they think about is, oh, this is an ironclad agreement that we've signed on in blood, in paper, and nothing will ever change. But that's not really the function of a data contract. Data is very different than software. In software, most quality issues can be predicted more or less deterministically, right? I come up with a plan for a feature. I write out my code in my architecture. If my feature does not work according to the plan I've created, it's a bug. Something's wrong. But in the data world, I, as a data consumer or data developer, might have one perspective on the data. There's an expectation that I maintain. And my data producer might have a completely different but equally valid expectation of the data. And if those two things don't align, there's a data quality issue. So data contracts are not about preventing your data producers from making changes. It's about enabling your data consumers to understand what's coming and helping your data producers take ownership of whatever those changes are. Okay? That's why I have my little Lao Tzu quote right there. So what is a data contract foundationally? Well, it's like an API for data. Why not just use a regular API? Well, in short, because there's a lot of things that data teams care about that a typical API does not care about. For example, yes, schema is obvious, but also the semantics of the data. What does it mean? What are the SLAs of the data? How frequently do we expect data to refresh? What is the underlying business logic that composes any particular column or data set? And what are all the governance policies that we need to attach to that data? Who should have access to query it? And there we go. I just covered that. So when you start moving to a more contract-driven world, what it means is that these data domain teams in the data mesh are maintaining data products and data contracts. The consumer teams are subscribing to these data contracts, And if change happens, if new data is added that needs to be pushed to a downstream system, or if an existing data asset that already has a dependency is updated, then that context is communicated to everyone that's leveraging that data downstream. Okay, so what's a really ideal approach here, in my opinion? You can do this if you own a data platform by going to your producers and saying, hey guys, we will not accept any data into our platform that doesn't have a contract. And how does that contract materialize? Well, it could be documentation in a Confluence page. I prefer it to be more programmatic and based in code, so like a YAML file or a JSON file. But ultimately, you just want the description of what the data should represent and who owns it to be clearly documented somewhere. Now, if you want to get into the more programmatic management of data contracts, then yes, you will need to do this as code. This ultimately ties into something I call dev data ops, which sounds a bit silly. Everybody's just throwing ops on the end of engineering-related words these days, but it actually does have a precedent. There is a field called DevSecOps, and what DevSecOps is all about is incorporating DevOps best practices into the field of security engineering. Why is that happening? Because security engineers realized the same things that we are realizing in data about 5 years before us. That if you decouple security teams from the software teams that are writing the code, you will always be in a permanently reactive state. Right? Security will constantly be responding to fraud, responding to hacking, instead of preventing hacking through good code hygiene. All right, so what are the components of dev data ops? I'm not going to spend a huge amount of time here. Data contracts are certainly one component, but all the tools and the techniques from security also apply to the data space. So static code analysis, understanding when a change is made to code, what will it impact downstream? Metadata-based code review. So instead of that person who writes SQL reviewing Java code, you're actually reviewing the metadata, the context of what's changing over time. Integration testing and unit testing, and also monitoring that is closer to the source and not just reactive at the analytical layer. So the sort of theme of dev data ops is that data producers should not need to change their tools or workflows because they won't do that. If you've ever tried to ask a software engineer to own a DBT model or own a Snowflake table, you will know that does not typically go particularly well. What works very well is if you ask them to own the tools and the processes they already maintain and use every day. So here's a quick example of that. This is a real-life flow where a change has happened in an S3 bucket to a data asset that is ultimately used in a data product. This is a CSV. When the file is updated, you then compare the new state of that file to what's been defined in the data contract. If there is a mismatch, then you decide what to do. And that might mean alerting. It might mean pushing that data into a quarantine zone and protecting your consumers. And you can do this for code as well. So here's a bit of a visual of this happening in practice, where you've got a code change being made on the left side, and on the right side, you are detecting that your data contract has been violated, and you're giving that feedback to the developer in their workflow. You're helping them understand, hey, someone else in the company is using this data for something, and you're about to cause an incident for them. So one of the things I get asked about a lot is data contracts for third-party tools like Salesforce and HubSpot and SAP. There's a whole spectrum of managing this that unfortunately I don't have time to go into today. Again, if you have questions on this piece in particular, come and see me after the talk. I'll be around. So the maturity curve for data contracts basically looks like this. You start off at data foundations, right? I just need to build my platform. I need my storage and compute environment. I need my ETL system. I need some way to do transformations. Then you start saying, hey, I'm running into incidents. How do I check to see if how many incidents were even happening? And then finally, you move to preventing those incidents. Ultimately, this is all about creating visibility over time, right? If teams understand the visibility, they understand where their data is going, who's using it, where is it coming from, they can start talking to each other, and talking to each other is what begins to create that cultural change. That's my time. Thanks, everybody.